I'm on page 23 in the exercise book. We're dealing with scales. And on this one, I haven't really shown you how this works, so I went ahead and drew a sketch of that picture. Your book picture is much better. But number 22 tells us to consider the scale, the map shown, and then to find the actual distance in miles between small Smithtown and Bullville. So it gives me the scale that 1 unit is the equivalent of 15 miles. What it does not give me is the other number to put in this proportion. But I do know that I'm looking for miles. So we're going to have to come up with the units between these two areas. And that's where this picture is so important. I'm going to erase this just so I can get a grip on this thing. What we're doing here is saying, okay, how many of these, and I just guessed at this, how many of those units does it take to fit between those two places? So you can tell that I was a little bit off, but I was just trying to. It takes 2 of those units. Now let me show you that again. I put one of them up there and then another one. So it took 2 of those to get to that next city. So I'm going to say that it was 2 units between the 2 cities. So I'll multiply 15 by 2 to get 30. And 30 divided by 1 is going to be 30. So it is 30 miles between those 2 cities. And that is, wow, not one of my choices. So I'm going to say that I'm a little bit over the amount, or maybe I'm not quite enough. Let me look at the answer, because without a ruler, I can't really tell you. Bear with me just a minute. It's D. Okay, so when I drew my picture, I didn't draw it wide enough. Let me try this again. Let's put this, whoops, I'll try here. Okay, so 1 unit is there. There is another unit here, and you see that there's a little bit more space right there that I didn't account for. I didn't quite make it all the way to Bullville. So it's that piece that we're going to have to work with. So I'm going to say that it's 2.5 units. And that's where my math will change down here. So 2.5 is going to be, let's see what we get with that. So 15 times 2.5 of those little units will be hopefully a little bit better. Yes, 37.5 divide 1 is still 37.5. So I like answer D as well here. So you may be thinking, how in the world will I do that on a test if I can't move things like that? What I would recommend if you have this problem on a test is that you take your scrap paper and you mark this distance right here. And then you use your scrap paper sort of as a ruler to see how many of those units fit between your 2 points. I truly would not expect to get that on a test, because you really can't know for certain without measuring it somehow. Okay, number 23. Jessica is 5.5 feet tall and casts an 8-foot shadow during the day. So I'm going to draw Jessica. Try that again. So there's Jessica, and we know that she is 5.5 feet tall, and that her shadow is 8 feet. A tree, at the same time, a tree casts a 14-foot shadow. So the tree is growing on the ground. Here's its shadow. And we want to know that assuming the height of the tree, assuming the ratio of height of an object to its shadow is proportional, so they're saying that height over shadow and let me just go ahead and put in the sun for you, just so you can visualize this. Here's the sun. You can see how this has practical applications to science. All right, so assuming that it is proportional and the sun is shining at the same time of day, what is the height of the tree rounded to the nearest thousandth of a foot? So we are going to just continue this proportion. Jessica's height is 5.5 feet and her shadow is 8 feet. The tree, we don't know its height, we're about to, and its shadow is 14 feet. I used to take students outside and let them find the height of the flagpole. It's just a proportion. So we're going to say 5.5 times 14 is 77. And 77 divided by 8 is 9.625. That is to the thousandths place. This is tenths. This is hundredths with a TH. And this is thousandth with a TH. So that is in the proper position. So I'm going to go with answer B. The tree is about 9.5 feet tall, a little more than that. Number 24. The scale factor of a drawing of a building is 1 inch is 48 feet. So the scale is 1 inch to 48 feet. A drawing of the side of the building. This is a drawing. This is a model, not the actual building. I'm going to draw the actual building. Let's stand him right here, and then we'll draw the model for that building. Is 6.4 inches long. What is the actual length of the side in feet? So we have 6.4 inches and 1 inch on the model matches up here. These are inches and inches. 48 feet will correspond to that 1 inch that we just drew. And then this dimension, as long as it's in feet, will be okay. We don't have to convert everything to inches. As long as the dimensions match here and here, we'll be fine. So let's set up the proportion of, I'm going to use model to actual. And the model is in inches. The actual is in feet. So 1 inch on the model corresponds to 48 feet on the building. And we know the 6.4 on the drawing. So let's multiply those two. 48 times 6.4 is 307.2. Divide that by 1, and that is still 307.2. So for number 24, I like answer E. Number 25. Mike's regular pentagonal garden has sides measuring 8 feet. Now let's stop right there because that is a scary thing to think about. Let me see if I'm trying to find a pentagon. I don't think I'm going to be able to, so let me go ahead and draw one. Gracious. A pentagon has 5 sides. It's like the Department of Defense building in Washington. So it's something, any 5-sided shape is a pentagon. But that's not too bad, is it? Let me make a copy so I won't have to do that again. All right, so Mike's regular, that means that all of the sides have the same length. And this is Mike's. Have sides of 8 feet. And all of these are in feet. His neighbor builds a similar garden with a scale factor of 3/2 to Mike's garden. So here comes that mama-baby thing. Mike's garden is the baby garden, and this is the neighbor's garden. If it's similar, it's a regular pentagon. So whatever these sides are, they're all the same. The scale factor, remember that's what you multiply by. So if we take 8, which is Mike's garden, times the scale factor that we're given on our calculator, 8 times 3 fraction 2 is 12. That will give me the neighbor's sides. What is the perimeter of the neighbor's garden when perimeter of a regular pentagon equals 5 times 12? 5 times the side. And we're going to put the side being 12. So the perimeter is 5 times 12, or 60 feet. So I like answer C on that one. That is a geometry question. And number 26. A wall in a new house has a height of 17 feet and a width of 19 feet. So let me just sketch. That looks like a wall that I built. So here is 17 feet high and 19 feet wide. In a photo of the house, so if this is the real wall, what's the photo going to look like? Is it going to be bigger or smaller than the real wall? It's going to be way smaller than the real wall. So let me erase these dimensions. But it is proportionate. In a photo of the house, the width of the wall is 0.5 foot, or half a foot. What is the scale factor of the photo compared to the actual wall? Well, I need to take the sides that correspond. So we have the 17 that matches up to the 0.5. So we want to know how we get from 17 down to 0.5. Well, I'm going to divide 17 by 0.5. And that tells me that I would be dividing by 34. 17 divided by 34 is 0.5. But remember, a scale factor is what you would multiply by. I just realized something. Did you catch what I did? Let's leave this down here. Nothing's wrong with that. I hope you caught it. There's my mistake. The 0.5 is not the height of the wall, it's the width of the wall. So it can't sit there. It has to sit up here. And will that make a difference? You better believe it will. Because the similar side is not there. The similar side is up here. So I was just about to blow that problem. And I looked down at the book and I saw the width of the wall is 0.5. This is the width. This is the height. So this is what the scale factor will represent. So I need to go from 19 down to 0.5. So let's do 19 divided by 0.5 and we get 38. So 19 divided by 38 is 0.5. But a scale factor needs to be written. This goes back and forth. Some teachers require it to always be a multiplication problem. I'm going to tell you that it can be either. The answer that they're looking for here is 38, so I'm just going to leave it there. I'm not going to go into the multiplication and all that. You could argue that I'm wrong. I've had instructors that would do that. But this particular book seems to go back and forth on that. When I was in school, it had to be a multiplied factor. So I would have had to say it was 1 over 38. Because if you multiply 19 times 1 over 38, you're going to get a half. And that's how my teachers made me do it. This is a little bit hard for me because of that, because their answer here is E. And that is 38. That's tricky to me. But the answer has to be E because the proportion is based on a 38th. All right, while I've got you with me, let's check these just to be sure. And this is page 23. So we have number 22 is D as in dog. 23 is B as in boy. 24 is E as in elephant. 25 C. 26 E. And I thought we're done, but we have another page evidently to do. So I'm going to stop this video and we'll check back for the next one.